function operations and composition. So first we're just going to do add, subtract, multiply, and divide for functions. We have two functions and we want to add them together. We just add them together like normal polynomials. But when we want to find the domain functions, when we add two functions together, we're creating a new function. And when we want to find the domain of the new function, first we find the domain of this one, the domain of this one, and they say, what's the intersection of the two domains? An intersection just means, what do they both share? The intersection of A and B. It means, what do both domains share or have in common? Okay, so the domain of F, what is the intersection between the domain of G? So that's how we find the domain for all of these new functions that we create through add, subtract, multiply, and divide. But restriction, because this is a fraction, say I take the fraction 10 over 0. Well, we can't have a 0 in the bottom of a fraction. What we do is we say, okay, the domain is the intersection between this domain and this domain, or the domain of F and the domain of G, but we have to make sure X. We say, okay, but we have to check, can G of X ever be 0? And if it can, we remove that from the domain. And we'll talk about that in a bit, so you understand. So let's look at a few examples. So here's my function F, and here's G, and I want to add the two functions together. So this says, take f of x and add to it g of x. So we're just adding two polynomials together. Well, 5x plus 3x is 8x, and I lose 2 and I get 1. Well, that's negative 1. Well, if I subtract, okay, this is my function f of x and g of x, and if I want to subtract them, remember you have to distribute the negative throughout, so that'd be negative 3x plus 2. So be careful with the brackets there. Okay. Then if I multiply the two functions, I have to do this times the first, this times this one, this times this one, this times this one. So we have to FOIL. We have to multiply those out. Okay. And divide, sometimes when you divide, you can't really do anything. Okay. And to make that more simple, you just sort of leave the two polynomials together like that. So now if I want to find the domains of these functions, well, if I look at this function here, if I wanted to graph this, I would say, because this is x to the 1, this is a straight line, and this is x to the 1, it's a straight line. So I have two straight lines, and what's the domain of a straight line? Well, that's the domain of F, that's the domain of G. So if I want to find the intersection of those two, I say, what do they have in common, or what do they share? Well, they share everything. And so the domain of this new function that I've created has this domain. And I do that for all three of these, for add, subtract, multiply, and divide. But when it comes to divide, I have to say, okay, what's the domain of F? What's the domain of G? What's the intersection? I take this, but then I do one extra step. I say, because this is a fraction, this can never be equal to 0. So I have to set the bottom to 0, to say not equal to 0. I'm going to solve for x and say, my domain is this, but in addition to this, I have to say x can never be equal to 2/3. So originally, negative infinity to infinity, this is my domain for all of these answers, but this one on the bottom, x can't equal 2/3. So at 2/3 right here, I have to say there's a hole. We cannot allow x to be 2/3. So then I say my domain is going to be from negative infinity to 2/3. And put that, ooh, I think that should be union. I made a mistake there. And then the other side should be 2/3 to infinity. And I use round brackets because it cannot be equal to 2/3. There's a hole. So these have to be round brackets. Okay, so it's like all real numbers, but not 2/3. So let's look at some examples. So I have two functions, f and g, and I have to add them. So I'm going to go f of x plus g of x. Here's f of x. And I'm going to take my brackets off because there's nothing in front. And here it's just add in front, so I can take the bracket off. And I go, oh, I can't put them together. So I just leave it like this. Now if I want to subtract these two functions, I go f of x subtract g of x. So now I'm going to go, okay. And because there's nothing in front, I can just take off the bracket. Oops, take it off. And because there's only one thing inside this bracket, I can just take the bracket off. And I can't make this more simple, so I just leave it like that. Now if I want to multiply it, it says multiply. This dot means multiply, so multiply f of x by g of x. Well, I could multiply the 8x by this and then the 9 by this, but then it gets kind of bigger, not more simple, so I'm just going to leave it. Now divide. So f of x is on the top. And I can't really make it more simple, so again, I just leave that. So you can see that this is the short form of saying f of x subtract g of x. So you understand that this means this, okay? So now that we found these new functions, I took the function f and I took the function g, I put them together with add, and I created this new bigger function. My next question says, state the domain for each function in question 1 to 4. So now I have to find the domain of all these functions. But if you remember, the rule is when I add, subtract, multiply, or divide, my domain is just the intersection between these two domains. So I have to find the domain of f, the domain of g, and then just sort of stick them together with intersection. It says what they have in common. So first we have to find the domain of f. Well, this is just a straight line. You say, how do I know? The exponent on x is a 1. Okay, so that means that this is just a straight line. So what is the domain of a straight line? Well, it goes forever and ever and ever and ever in this way. So it's going to use all the positive values of x. And it goes forever and ever this way. It's going to use all the negative values of x. So that's my domain of f. Now I have to find the domain of g of x. There's different ways to do this. I'm going to show you, well, do you remember what this looks like? If I look at the graph of this, the graph of this looks just like a square root sign. So if I graphed it, it would look like this, which kind of looks like a square root. Okay, that's how I remember it. And, well, the square root function only exists on the positive side of x. Okay, another way to think of it is, well, when I have my square root, I can't put negative numbers in here, because if I put a negative number, let's check, say the square root of -10, what's going to happen? There's an error, because you can't put negative numbers in here. So what you have to do is you have to say, whatever's under the square root, it has to be bigger than or equal to 0, which means it can't be negative. So now we solve for x. So 2x minus 1 has to be bigger than or equal to 0. Add 1 to both sides. So that's 2x is bigger than 1. get x by itself, divide by 2, divide by 2. So x has to be bigger than, and I'm going to write it as a decimal, half. So x has to be bigger than a half. So let's just draw a number line. So there's negative infinity, there's 0. Here's a half, okay? So this one for f, let's look at f, has to be, the domain of f is all the way from negative infinity to infinity. But the domain of g says it has to be bigger than a half. Can it be equal to a half? Yes, because there's an equal sign. So let's color that in. So this is the domain for g of x. And so we have to say, what do they have in common? Well, the only part that they have in common is this part here. Okay, so this is the part they have in common. That's the intersection of both of these. So intersection, this little thing here, says what do they have in common? They have this part. Okay, that's the common part. So it goes from 0.5 to infinity. Oh wait, can it be equal to 0.5? Because there's a solid circle here and it can be equal to it here, it has to be a square bracket here. Because it says it can be equal to this 0.5. So the domains of add, subtract, multiply for these two functions is this. Oops, square bracket. But when we do divide, we have to check one more step. Okay? Whatever's on the bottom of this fraction, we have to say this cannot be equal to 0. So what was it? When we did divide, it was equal to this. So I'm going to copy this down underneath. So I'm just copying it down from question number 4. So f of x, g of x, oh, that's like way too big there, is equal to, so we have to check and we have to look at this and say this cannot be equal to 0. So I have to say the square root of 2x minus 1 cannot be equal to 0. So how do we get rid of this square root? Well, what's the opposite of a square root? Kind of square. So I'm going to square both sides, and the square root and the square are kind of opposites, so I just cancel them out. So now I have to solve for x. So add 1 to both sides. Divide by 2, divide by 2. So x cannot be equal to a half. So when I divide, this is my domain. But I have to add this to it. This says my domain, it can be equal to 0.5 up to infinity. But this says, ooh, take out the x equals 0.5. So I have, it was going to be this, but now I have to rewrite it and take out the, it says it cannot be equal to 0.5. So I have to take this out and say, now it's this. Because this says it cannot be equal to 0.5. So I have to just add one extra restriction. So here's my extra restriction, so I have to change this one a little bit. So add, subtract, and multiply are easy, but then divide has one extra step, and this says don't let x equal 0.5, so we change it. Okay.